Welcome to topic number 23, gradient of a curve. How can we find the gradient of a curve? At the end of this lesson, students should be able to apply the most basic principle that is used in finding the gradient of a curve. The method used is by no means the most accurate. In order to ensure that the calculated gradient of a curve at a point on it is accurate 100% of the times, calculus has to be used. It is, however, worthy of note that the principle used in calculus has its beginning in the ones that will be taught in this lesson. Some of my CAPE students were not taught the basic principles by their sex teachers, and they encountered some difficulty understanding the introductory steps in calculus. Whenever students in a class are trying to determine the gradient of a curve at a particular point, it may be that no two answers are the same. Finding the gradient by the method soon to be discussed, is at best an approximation. There should be no alarm if a variety of answers are obtained. So now we are going to be looking at the gradient of a curve, and we are going to be looking at secant and tangent. Some may pronounce it secant. My ancient mathematics teacher said secant, and I'm using that word also. So secant. If a straight line crosses a curve at more than one point, it is said to be a secant to the curve. So we have 2 points of intersection right there as the arrow points. The arrows point out that we have 2 points of intersection. So, of course, that line is a secant. If the secant is adjusted in such a way that it is in contact with the curve at a single point, it now becomes a tangent. So we're going to see the secant now is being adjusted so that it has only 1 point of contact. So that single point of contact is called a point of tangency. So that line becomes a tangent. The tangent is defined as the limiting point of the secant. That means the secant can go no further. If it goes beyond becoming a tangent, it is no more in contact with the curve. And we know that it is no secant at all. The gradient of a curve at a point is a gradient of a tangent to the curve at that point. That means if you're going to determine the gradient of a curve, you have to draw a tangent to the curve. So this means that in order to determine the gradient of a curve at a specified point, a tangent must be first drawn to the curve at that point. Take note that the tangent should touch, not cross, the curve at one point only. The line should not be in contact with the curve for too long either. We know already that given 2 points, the gradient of the associate line may be found. So find 2 convenient points and use them to find the gradient. So let's see how that is done practically. So we have that curve on the left, and for that curve we are going to find the gradient at 2 points. We have the 2 points where x is equal to -2 and where x is equal to 3. So we are going to find the gradient of the curve where x is equal to -2. Therefore we are going to draw our tangent where x is equal to -2. So here is where x is equal to -2, right there. So first we need to locate the point on the curve where x is equal to -2, where the x value is -2. So that is the point where the x value is equal to -2. So at that point we are going to draw the tangent. So there is our tangent. So we're going to take our tangent. Remember from equation of a straight line that if we can find 2 points through which a line passes, we can determine its gradient. So we are going to use the grid to determine that. Oh, we have 2 points there. One point is -3, 6 here, and the other one is -1, -6 right here. We are choosing points conveniently in order that we do not have any fractions in our calculation, makes it a little bit smoother for us. So you can choose any 2 points through which the line, the tangent, passes. And those are the points that you're going to use to determine the gradient of the tangent at the point where x is equal to -2 hence the gradient of the curve at that point also. So use the point -1, -6, and -3, 6 to find the gradient. See our old formula coming again. M is equal to y2 minus y1 over x2 minus x1. And of course, we know the reverse one is also applicable. y1 minus y2 divided by x1 minus x2. Of course, we're going to do our substitution. So we have done our substitution by saying 6 minus -6 to be divided by -3 minus -1. So we have it right there. M is equal to 12 divided by -2. So let's say that again. We have here 6 minus -6 and -3 minus 1 minus -1. And that is going to be used to find our gradient. And of course, manipulating your directed numbers in a second, we have M is equal to 12 divided by -2, which will turn out to be M is equal to -6. That is the gradient. And of course, we need to find the gradient of the curve at the point where x is equal to 3 also. So let's do that. Here is where x is equal to 3, right here, right at that spot. So this is the x value, 3. So the curve, corresponding value for the curve is right there. Draw the tangent where x is equal to 3. First, we need to locate the point on the curve where x is equal to 3, or the x value is equal to 3, which is right there. Then, we draw the tangent to the curve, right there. Find two convenient points and take note of their coordinates. So we're going to use 2 points on the tangent. So find 2 points that are on the tangent line. Good. And they must be chosen conveniently, well, as long as it is possible, chosen in such a way that there is no fraction to encounter. Use the points 5, 2 and 2, -9 to find the gradient. Of course, we're going to use M is equal to y2 minus y1, and we know what to do with that. And when we have worked that out, we get M is equal to 11 over 3, or M is equal to 3.67. I have used calculus also in finding the gradient of the curve at the specified points. The first gradient that was found was the exact value. In the second case, the answer was a little bit off. Calculus gave 4, and I got 3.67. These results would be considered to be more than I bargained for under the circumstances. In finding convenient points, one should try to get the points as far apart as possible and avoid using fractional values. In a few cases, students may not be able to find points through which a line passes that will not give fractions. In this case, fractions may be used. Take note that the points that are used to determine the gradient must be points through which the tangent passes. This method of finding the gradient will not be redundant when you start studying calculus. If the equation of a curve is not known, its gradient may only be found by using this same method. And of course, as I said before, the value for the second one that calculus gave is 4, which is the exact value. And I got 3.67, which is very, very close under the circumstances, because when the equation of a curve is determined in this manner, it is subjected to many, many different types of errors that can cause the answer to be a little, or in some cases, way off from the correct exact value that one should get.